Hello viewers, you are on to Mathematics with Dr. OJ. In this video, we shall look at application of set theory. That is basically we want to see how set theory can be applied to arithmetical problems. Don't forget to subscribe to my video channel by clicking the subscribe button below the video and the notification bell so that each time I upload new video, you will be duly notified. Thank you. Now, let's consider the Venn diagram below. Consider the following Venn diagram. So let's suppose we have this. Okay. Now we call this A, call this one B. These are what? Universal sets. Let's call this portion X, let's call this Y, and let's call this Z. Okay, now suppose A and B are finite sets. Let A and B be finite sets. What do I mean by finite sets? Sets that have definite elements in them. Okay? And the number of elements in them is definite. Okay, now, so let's number of elements in A be denoted by n of A, and number of elements in B, that is in subset B, okay, be denoted by n of B. Don't forget the A and B are subset for the universal sets. So now they are subset of the universal sets. That implies that therefore hence the number of elements in subset A, is equal to, now looking at the number of elements we have in subset A, the number of elements we have in subset A cannot be bringing the values of X, because in subset A we have X, we have Y, so that will be X plus Y. The number of elements we have in subset B, that will be what? Y plus Z. Okay, are we together? Yes. Okay, now there is an intersection between A and B. That is, we have the number of elements we have in intersection equals to Y. Okay, as you can see. Now let's carry out some simple arithmetical operations. Let's carry it out. Now, if we want to find the union of all the elements in A and B, now the union of all the elements in A and B, let's see. That is bringing all these elements together. The union of all the elements in A and B we should what? X plus Y plus Z. That's how it should be. When you bring all the elements together, that should be the union. But in this case now, suppose from what they have had, suppose we say we had this, and we equally had that, or we subtract that. What are we going to have? Okay, so that means we can say that X plus Y, which is for A, plus Y plus Z, which is for B. Now, suppose we subtract Y. Let's see what we're going to have. Because if we say X plus Y, Y plus Z, Y is a point of intersection. So it's like we are repeating that Y, more than once. So let's look at it. So if we open up this one, we have what? X plus Y. That is 2Y plus Z, then minus Y. So by the time we evaluate this, we have X plus 2Y minus Y plus Y plus Z. So that has given us what our number of elements in the union of A and B is. So that implies number of elements in A union B, okay, will be equal to number of A That's element A plus number of elements in B, then minus number of elements in A intersection B, because our Y stands for A intersection B. I hope that is taken. So in this case, we have established a very standard and useful set formula. Okay. Now let's now consider. Now we're going to consider when we have three subsets. Now let's consider when we have three subsets. Suppose A, B, and C are subsets of a universal set U. We shall find the set formula for the union of A, B, and C. We want to find the formula for the union of A, B, and C. How do we go about that? Please don't forget, this formula is very useful. So that means number of A union B union C could be, let's say, to get that, let's assume that actually that's what we want to find. Now let's B union C be equals to D. Okay, let B union C equals to D. So that means I want to find that number of A union B union C. You know, it's the same thing. We can say it's the same thing as number of A union B union C. I hope you understand. If we factor it out like that, okay, because it is commutative and it's associative. So we can have number of A union what? Union D, because we have said that our B union C should be equal to D from that assumption. So this implies that, so we can now say that n of A union D, is going to be what? It's going to be number of A from this formula plus number of D, that's element in D, then minus number of A intersection D. We're going by this formula. Okay, going by that what? By that formula. Okay. Now, this one will give us, that is, number of A union B union C, which is for this, is now equal to number of elements in A plus number of elements in B union C, don't forget, minus number of elements in A intersection B union C. This I hope you are following. Okay, so this one could now be what? This one could be, I'm talking about the right hand side, number of A plus number of what? Of B plus, it's B union C, plus number of C, because number of B union C itself is number of B plus number of C minus number of B intersection C. So we can say that minus number of B intersection C, then minus number of A intersection B union C. I hope you are following. Okay, good. So with this, now we can now carry out a kind of distributive evaluation of this. So this one will be what? Number of A plus number of B plus number of elements in C minus number of elements in B intersection C, then minus number of, we can actually expand this so that we won't run into trouble. Number of A intersection B, union number of A intersection C. Okay, that is by distributive laws, A intersection B union A intersection C. Okay, so with this, we continue using that our primary formula. We continue using our primary what? Our primary formula. So now what we need to do is now to factor out this. We need to factor out what? This. this one will now be equal to what? Number of A plus number of B plus number of C minus number of B intersection C, then minus, now this one is like A union B, and you know number of A union B will be number of A plus number of B minus number of A intersection B. So this one will not be what? Number of, you know, now A intersection B, then plus number of A intersection C, then minus, now it's intersection of A intersection B intersection A intersection C. When you bring them together in terms of intersection, you have what? Number of A. Don't forget, you have to put brackets here because of this bracket. Then intersection B intersection C. Okay, intersection. Let's write it properly. Intersection of A intersection B intersection C. Good. So which will now give us, that is the original thing, a number of A union B union C will now be equal to number of A plus number of B plus number of C plus number of C minus number of B intersection C, then minus number of A intersection B, then minus number of A intersection C, then plus number of A intersection B intersection C. So we can rearrange, which implies number of A union B union C is now number of A plus number of B plus number of C minus number of A intersection B minus number of A intersection C minus number of B intersection C, then plus number of A intersection B intersection C. So with this, we have established a general formula for solving set problems involving three subsets. Please don't forget, subscribe to my video channel. God bless you.